Good. Okay, so Philip, it's already recorded. So welcome on our DataOps Poland meetup. Here is Anais from Influx Data. So Anais, stage is yours, and you are our star. Go.
Okay, thank you so much, and thanks for having me here. Yeah, I'm Anna Eastodis Georgiou. I'm a developer advocate at Influx, and today I'll talk about Flux, which is the query and scripting language for InfluxDB, and edge data replication. So if you want to connect with me, I invite you to do so on LinkedIn. I have 2 cute cats, and I hope they brighten your day like they do mine. A developer advocate is someone who represents the community to the company and the company to the community. So I spend a lot of my time answering questions on forums and Slacks, answering questions and asking them, writing tutorials and blogs, and presenting at meetups and webinars and conferences. So today, what we're going to go over is the InfluxDB platform and give an overview of that first. So Influx Data is the creator of InfluxDB, but most people are just familiar with InfluxDB. Then we'll talk about Flux, which is the scripting language for InfluxDB, and we'll talk about all of its capabilities. Next, I'll give some real-life examples of how to use Flux and what Flux looks like so you can get a feel for it. Then I'll talk about edge data replication. Oh, that was cool. I just got like a question. Oh, I raised my own hand. Did someone else raise a hand? I saw like a notification, but I don't know what it was about. Yeah, and if at any
you're interacting, you are your host, so if anyone joined, it will be some notification.
okay.
So let me or the Philip will accept it. So that's it. Okay.
Okay, cool. Yeah, but if anyone has any questions at all, please feel free to just go ahead and ask them or put them in the chat. Happy to answer them in real time. Okay, so and then I will talk about edge data replication and give an example of it. And I will not actually be doing a demo today, but let's start with the InfluxDB platform overview. But before we actually go into an architecture diagram to understand what InfluxDB is, first, it's important to take a step back and understand why we would use InfluxDB. So InfluxDB is a time series database platform. And time series data is any data that is or has a timestamp associated with it. 1 second, because I moved everything around. So give me a quick second. I'm losing all my slides. And so we see time series data arriving and being collected from a bunch of different sources. In the physical world, we can think of time series data coming from a lot of IoT devices. So sensors on the factory floor or in the field, and maybe in vehicles or in space. And then in software applications, we see time series data being collected and generated from monitoring use cases. So whether you're monitoring VMs, containers, third-party endpoints, microservices, networks, storage and compute resources, et cetera, those are all sources of time series data. And then from applications, one of the first ones that always comes to mind is fintech. We also see time series data coming from agricultural and energy applications and retail point-of-sale transactions. So in essence, time series data is pretty much everywhere. And that's where Influx Data and InfluxDB comes into play. So Influx Data has created really 2 main products. The first is InfluxDB, which is an entire time series database platform. And the second is Telegraph. Both are open source, but InfluxDB is also offered as a cloud offering as well. InfluxDB is not just a purpose-built time series database, but also a visualization layer or UI and a data processing engine as well. And Flux is used as a query and scripting language for that data processing engine. So with InfluxDB, you can collect data, you can transform your data, you can downsample your data from raw, high precision data to lower precision aggregates, or in other words, create materialized views of your data. You can also create and write triggers and alerts on your data. And then we have Telegraph. Telegraph is a collection agent for metrics and events. It's plugin driven. Both InfluxDB and Telegraph are downloadable as a single binary. Telegraph has over 200 input plugins alone. There are also processor plugins, serializer plugins, aggregator plugins, and output plugins. And it's extremely lightweight, and you can reduce the size as well to only use the plugins that you are concerned with using. It has batching, buffering, and caching capabilities as well. So if you have a challenge of getting data from a data source and writing it to somewhere else, and you want to take advantage of all the functionality and capabilities that the Telegraph agent provides, or collection agent provides, then I highly recommend looking into Telegraph. It's also relatively easy to contribute to. In fact, I think like 90% of the input plugins, for example, have been contributed to by the community. So if you're looking to get involved in a project where you can make a contribution, it's another great place to look. What else about it? There's also these plugins called the exec plugins. There is an input exec plugin and a processor exec plugin, and they make Telegraph extensible in any language. So you can take advantage of all the agent capabilities that the collection agent has to offer, like buffering, caching, flushing, etc. But you can then extend it to collect or process data in the language of your choice. A while ago, I did a little project where I used the Telegraph execd input plugin to gather temperature data from an OCR OCR reads the thermometer of this person's homebrew setup where they were brewing beer, and created little mini micro forecasts, and then was able to give the brewer enough notice to go ahead and change or alter the temperature of their homebrew setup so that they would create the best beer that they could. And so Telegraph was used to not only collect, but also then process that data and create miniature forecasts with Holt-Winters function, or triple exponential smoothing. And then we used Flux within InfluxDB to actually create alerts and send notifications to Slack when it appeared that the temperature was going to be outside the appropriate limits. There are also over 14 client libraries that you can use to manage and read and write data to InfluxDB. My favorite, I love Python, so my favorite client library is Python, especially within the data science world and DataOps world. The Python client has direct support for pandas data frames, so I find that really convenient. And then also it's worth noting that Jupyter Notebooks and Zeppelin Notebooks also have built-in interpreters for Flux, or there are Flux interpreters for them. So if you want to take advantage of Zeppelin and Spark and parallelization for really, really large data use cases, or you're a fan of Jupyter Notebooks, I recommend looking into those interpreters as well. Okay. There's a lot of time spent there. So let's get into some specifics. All right, so talked a little bit about Flux. Hopefully now we know that it's the data and scripting language for InfluxDB. And this is what it looks like. So Flux allows you to build data pipelines to query your data, analyze your data, and transform and act on your data. The perks of Flux, you might be saying, like, why would I use it? The main perk is that these analytics are happening server side rather client side, so you get increased performance. And also it is a unified language across the entire InfluxDB platform. So if you are looking to do anything within InfluxDB, whether or not that is creating a task to process your data on a user-defined schedule, create an alert, or create some sort of trigger, all of those things, while you can do them within the UI behind the scenes, those are all executed with Flux, so it's kind of worth learning. Another advantage is that you have the option to perform this sort of processing and data pipelining at the database level, and so you aren't required to pull in a third-party client application to do it. And just to summarize, at its most basic level, Flux allows you to query for time series data. It also allows you to manage your time series data lifecycle and set up things like downsampling and materialized views. It allows you to alert on your data, analyze your data, clean your data, and transform your data. And so essentially this little script here on the screenshot is an example of Flux. The first thing you would do is import any packages that you want to use as a part of it. Then you can query your data and assign a variable to it if you wanted to, for example. So the most simple Flux query would start off with the from function, and you query your data from a bucket. A bucket is exactly like a database in the SQL world, except it also has a retention policy assigned to it. And that's a critical part of using and working with time series data, is the ability to automatically expire data that is too old, because time series data is almost always time sensitive, and you are almost immediately concerned with the data that is coming in now. And often, not always, you want to be able to expire data once it has reached a certain age. Of course, you're not required to set a retention policy, or in other words, your retention policy could be infinite. Then you would query for a range of data. And after that, you would filter for your measurements, fields, and tags. Measurements are kind of a sort of higher level grouping of your time series data. Fields are where the actual meat or value of your time series data would go. So if I was like querying or writing temperature data, and I was, the temperature was 23 degrees, then that would be what my field value would be. Tags are used to write metadata about your data. So a tag might be the city, Poland. And so in this example, what we're doing is we're looking at a bunch of bicycle data, rideshare bicycle data, and we're going to do a simple analysis where we compare bicycles from two different tags, the neighborhood ID, or two different tag values, the neighborhood, with the tag being the neighborhood ID. And we're going to look at bicycles from neighborhood ID 3 and neighborhood ID 4. Then we're also going to perform this aggregate window function on that data to aggregate this high resolution data to 1 hour averages, just so that we can kind of return a general trend of the data as opposed to looking at every single point. And that'll also just make our queries and our math faster. Then we'll go ahead and join those two results together. We'll do some quick data processing by keeping certain columns that we care about and dropping the rest. And then we'll use the map function to map across every row in all of these tables to find the difference between these two neighborhoods and see if there is one neighborhood where a lot more bicycles are being rented. And maybe that, cues people into knowing that we need to set up more stations in this neighborhood, or that maybe there's a deficit of stations in one neighborhood or not. So that's kind of just an example of what Flux looks like. So it's, kind of JavaScript-esque. It has these pipe forward operators that take the output from the previous result and pipe forward them into the next function. So if you are familiar with pandas, Flux does operate on a stream of tables. And so there is some overlap in the way that experience feels. So I've talked about this a little bit already, but what can you do with Flux? You can query with Flux, but you can query not only InfluxDB, you can query other databases as well. So there are SQL from functions. There are CSV.from functions as well. So if you have relational data, you should keep that in a relational database and pull it in ad hoc. So for example, imagine we were doing predictive analytics and we were performing predictive maintenance on sensors or parts in a factory. And we then wanted to determine that a certain sensor is faulty or a machine is going to need replacement. And we're using InfluxDB to do that. We're performing some sort of forecasting, and we determine, okay, some action needs to be taken. At that point, we could create an alert script with Flux that takes advantage of a SQL.from function, pulls in relational data about this particular sensor, maybe the purchase date, maybe the ID of the sensor, maybe the contact information of the person who is required or responsible for replacing this part, etc. And include all that information as a part of the alert so that the next person who is responsible for taking action on this failing piece has all the information that they need to resolve the issue. Then obviously you can filter. We saw that earlier. You can perform aggregations. You can also change the shape of the tables that are returned from Flux. So you can perform joins, pivots, unions. There's a ton of functions. As far as analysis is concerned, we can perform math across measurements. We can do some basic anomaly detection with thresholds, standard deviation, median, absolute deviation. There's a bunch of functions for statistical time series analysis, like correlation, covariance, skew, etc. There's downsampling that can be performed. You can also write custom functions yourself. So if we look at the aggregate function window here, which is on line 9 and 17, you'll notice that there's an FN parameter. We pass in a default function here, which is mean, but you could pass in any function that you want, any custom function that you wrote with Flux to aggregate your data in a unique way every hour. It could even be, a function that takes an action like creates an alert or writes data or who knows what. There's HTTP functions as well that would allow you to manage your InfluxDB instance as well. Then yeah, you can act on your data as well. So we can perform conditional logic, we can create checks, alerts and notifications, and output data to MQTT, also input data from MQTT, and HTTP as well. So a lot of options with Flux. So just to summarize, if I had to categorize some of the Flux functions from a data science perspective, I would think about them in these ways. I would say that there are functions for statistical time series analysis. I mentioned this already. Things like standard deviation, quantile, spread, skew, correlation, covariance, etc. Functions for dynamic statistical and fundamental time series analysis. A lot of moving averages, double moving average, triple moving average, exponential moving average, time-weighted average, derivative functions, etc. You get the idea. And then there's also technical momentum indicators for financial analysis. Those are also a lot of different moving averages, like Kaufman's moving average or Shonda momentum oscillator. And then we have a math package for all sorts of math applications. There's even a geo package to handle geotemporal data. And then last but not least, we can write and consolidate data from the edge or fog to the cloud with Flux. So you can use the to function to do that. Oh, sorry. So I just wanted to give some examples as well of some specific Flux functional capabilities that are related to time and help you handle time series data. And this point, I think, is especially relevant because when you think about time series data in general and time series databases, you have generally like one main pressing question, which is why do I need one? And the first answer is that time series databases are designed to handle the large ingest volume that a lot of time series data use cases require. So just to put things in perspective, if you have a R4 for Excel instance with InfluxDB, you can write around 800,000 points per second with a data set dimensionality of around 10,000 points. But of course, you're not necessarily going to have that type of use case. And then you might ask yourself, well, then if my concern isn't writing really high volumes of data to InfluxDB or a time series database, then why use it? And I would say then the reason why you would want to consider it is just that there are a lot of eccentricities when it comes to working with timestamps and time data, such as working across different time zones and all of the different functions that this slide addresses. So when you're working with time, you want to be able to select certain hours of time easily. You want to be able to convert timestamps to durations, look at how long a certain event has occurred for, return current times, the system times, convert timestamps back and forth, truncate times, add durations, align times together, work with time zones efficiently. And so these are all kind of like subtle details that, you could definitely maybe use a different database that will handle really high volumes of data, but then you need to maybe write or bring in this functionality from some other tool. And then another point that I wanted to address is that you might be asking, okay, well, why or how do time series databases allow for such high ingest volumes? And in InfluxDB's case, a lot of assumptions were made during the design of InfluxDB, and they all prioritize really high read and writes. So, for example, one assumption is that deletes will be a rare occurrence, because typically, like if you were gathering data at the nanosecond precision, if 1 nanosecond value is off or wrong, that's not going to usually make or break your use case, because it's really about the large volume of data, and you're not going to usually be concerned with updating or deleting that one point. So that functionality is deprioritized in favor of optimizing reads and writes. Essentially, like those are like all the design assumptions were made to do that. So yeah, I talked about the SQL from function. This is an example of using it. So you would specify the driver name, the data source URL, and then also your query. And then you could just bring that data in, and then you could join it with your time series data from InfluxDB. And in that sense, merge your two different types of data together. And in this way, you can also reduce cardinality, because you shouldn't be keeping relational data in a time series database. Then I wanted to talk about some more advanced Flux features. So you can also contribute third-party Flux packages as well. I contributed one that uses or creates the median absolute deviation function, and that is written entirely in Flux. And it's a really simple anomaly detection algorithm that calculates the median absolute deviation from all of the points across multiple series of like time series at a single point in time. And essentially, if the median absolute deviation is above, and this is a simplification of the algorithm, but essentially if it's above a certain threshold relative to the other points in those like series, then you know that you have an anomaly. And in this screenshot here of some generated data, we might not really be able to tell which series is anomalous, but the median absolute deviation function was able to illuminate that the purple series was in fact the anomalous one. So just in general, if you have that sort of problem, I recommend looking into this algorithm, because it's a really elegant, really simple solution. And then this is what a task would look like. So a task is a Flux script that operates on a schedule, user-defined schedule. And the very first thing you would do if you were to write a task is to provide the task options. And this would include the task name, as well as the every duration, which specifies how frequently you want to be running your task. Then you would define where you want to be getting your data from. And then typically, not always, you would query your data based off of the task configuration option or the every option above, but you don't have to. And then you would filter for the data that you're interested in, as always, and then you would maybe aggregate that data and then write that data somewhere else. So this is an example of a downsampling task. So you can also create checks and alerts within the UI. So the left screenshot in this example of creating a threshold check within the UI, where we are setting thresholds for critical levels, warning levels, okay, what levels, and info levels. And then we use the UI to create an endpoint. In this example, where we're making our endpoint PagerDuty. And then we create a rule for this notification kind of what sort of message do we want to include in the notification, and under what check conditions do we want to actually write a notification or submit notification. But while you can do this in the UI, it's worth noting that all of this is done with Flux behind the scenes. So under the hood, this would be the corresponding check. And so you can create your own custom checks and notifications, and there are a large variety of endpoints that you can choose to work with. So Telegram, Discord, MQTT, Microsoft Teams, ServiceNow, PagerDuty, a bunch. There's a ton. In fact, oh wait, listed them all, but there happens to be a slide. So yeah, you can see all of the different endpoints that are listed here. So now I wanted to give a little example of the hardest thing to understand about Flux, so that if you decide to pursue using InfluxDB, then you have a good idea of what Flux is, how it works, and what you can do with it. So I wanted to answer this question. If I was collecting fuel values across a lot of different generators, and I had a tag with a generator ID, how would I calculate the mean across various generator IDs? And the answer is that I would query my data, and I would filter for the different generator IDs that I'm interested in. And I'm going to drop all the other columns that I'm not interested in, like the start and stop column, which just tell me the range values that I have put in. So in this case, I'm querying from the UI, so I'm using a variable, which is the time range start, which is brought in from the UI. And I'm going to yield this result as raw, just so I can see what my data looks like before I actually calculate the mean. And so this is what I mean by Flux returns a stream of tables. So essentially, in this example, I filtered for 3 different generator IDs, generator 1, generator 2, and generator 3. So I returned back 3 different generator tables, or 3 different tables in this result stream. So you can tell that all of these tables are part of one result stream, because if you look in the first column, in the second row where it says table, the name of that result stream is called raw. So all of these tables are therefore part of this raw result stream that we've named. Then we'll also notice that there's an index for this table stream, and we have 0 through 2. So this is another indication that they are all part of the same result stream. And by default, the reason why we get 3 tables returned back to us is because essentially when you query with Flux, you're going to return every time series as a separate table. And a time series is defined, or a series is defined by the unique combination of measurements and tags. So in this instance, we're all looking at data from one measurement, gen data, but we're looking at data from 3 different tags. And so we're going to get 3 different time series for each generator ID. So if you would imagine plotting data for each generator ID, we would intuitively think that we would have 3 different lines time series, or 3 different lines in our graph. And that's why we return 3 tables. And then to reflect this, there are these things called group keys. And a group key is just where every row in a table is the same. So by default, the tags are grouped to represent each series. And so if I want to calculate the mean across all of these tables, I'm going to have to essentially ungroup our data, combine it all into one table, so that I can take all of those values and pipe forward them into a mean function. Because if I were just to apply the mean function right now, every single table in the table stream would individually get piped into the mean function, and we would return 3 different values. But we're interested in the mean across all. So essentially, I would group my data all together. You could either group with the group by or accept mode. It's up to you. To group all my data together to return just one table with all my values. We can see how the group keys have changed. You don't need to pay too much attention to it. It's just knowing that this is the hardest thing to understand about Flux. And if you understand this, then you are completely ready and good to go. So essentially, we just specified that the only thing that we want to group by is our measurement field and host. And since we know that those values are the same across all of our time series, we know that we will then be grouping our data into one big table together in preparation to then calculate the mean. And that's all we have to do. And just worth mentioning, a mean is a bare aggregate function, but there are a ton of bare selector functions as well. And our result would look like this. So yeah, so that is the hardest thing to grasp about Flux, is the group keys, but it's also where the flexibility comes and where the power comes with Flux, because you can manipulate these group keys to group your data based off of the timestamp, based off of combinations of different things. And so there's a lot of value in that as well. And before, I just wanted to mention that we grouped by specific columns, so that we could preserve those columns as part of the group key. But you don't have to do that. You could just use an empty group to just say, I just want to get all my data together, just ungroup everything, remove all of the columns from the group key. And you could do that instead. And so that's kind of like a way to not even have to think about it. And so if you want to learn more about InfluxDB, Flux, and Telegraph, I recommend looking into InfluxDB University. So we just launched this earlier this year. It is where you can get free courses on InfluxDB. And also you can gain a badge for your LinkedIn if you want to, and kind of flex. And there are, every course is free. Another cool thing about the badge is that if someone is on your LinkedIn and they're looking at the badge, they can actually view the details of what you had to do or accomplish in order to earn that badge. So that's kind of fun. And we continue to add courses to it as well. So now I'll talk about edge data replication. So edge data replication is a new feature of InfluxDB, and it appears in version 2.2. And this feature is used to automate the replication of time series data to other InfluxDB instances. So durable disk-backed queues, they add buffering to withstand planned and unplanned disruptions in network connectivity. And in addition, this feature configures replication at the bucket level so that any operators or developers can precisely define which sets of data that they want to replicate and where to send them. And if you wanted a subset of data that was in a bucket, you could first use a task to write that to a specific bucket with the to function, for example, and then, hello kitty, and then write that data from that specific bucket with edge data replication. And this replication happens on write as well. So when time series arrives at the edge or at the fog and matches a replication rule, then the OSS immediately mirrors that data to a remote bucket that's defined in the configuration. And when InfluxDB OSS cannot send the data to the remote instances, all events buffer in the local durable queue until connectivity is restored. And the size and retention of that durable queue are also configurable. And you can also write back and forth. So you can write from the edge to the cloud, but also vice versa. You're not limited to that. That's just the most common use case. So here are some use cases of edge data replication, just so we have a context for its purpose and the benefit. So first, let's look at retail. You might think of, for example, that we have a centralized cloud instance or data center, and in that we store things like inventory, logistics, and in-store pickup orders. But at the edge, we have POS transactions or point-of-sale devices, RFID tags, and loss prevention devices, and we want to be able to write data to and from the edge and fog to the cloud and vice versa. In manufacturing, we can think of manufacturing execution systems or computerized maintenance management systems as being like where we are storing centralized cloud data. And then at the edge, we have process control systems, we have equipment pallets, we have conveyors and lifts, we have flow gates, pressure sensors, et cetera. And we want to be able to write these data back and forth as well. And then consumer banking, we can think of Centralized data being things like transfer requests, market information, and transactional systems. And at the edge, we have things like ATM machines, branch office techs, and even customer mobile apps. So just to provide some context for edge data replication, I've talked about the to function, and this is a very straightforward way of writing data from OSS to cloud. And this is kind of the old way of doing edge data replication. But this is what it would look like, right? You use the to function to specify destination URL, and you would include your org ID as well as your token and your bucket ID in order to write data to the cloud instance from your OSS edge instance, for example, or vice versa. But there are limitations to the to functions. So the first is that it's sent over HTTP. The second is that there's no built-in functionality for failure handling, and there's no built-in functionality for batching retries or parallelization. And so that's why edge data replication was created. So tangibly, what edge data replication is in the backend is that the feature consists of 2 new API endpoints, the remotes and replication endpoints, and 2 new CLI commands, remote and replication. And yeah, and so essentially you can use, either the CLI, the API to configure the replication stream and the remote connection. So the remote connection is just a remote connection that determines that you want to connect like one bucket from this source to another, and the replication stream are kind of like the conditions of that replication. So this is an example of how you would create a remote connection. So you would need to first use the influx remote CLI command. That's my preferred way of doing it, is using the CLI. You would specify a remote connection name, the InfluxDB instance URL, the remote instance URL, the remote InfluxDB API token, and the remote InfluxDB organization ID. So this is assuming, for example, that you are using the CLI with a configuration of your local InfluxDB instance. Then you would use the replication create command to create a replication stream, and you would provide the following information: the stream name, the remote connection ID, the local bucket to replicate writes from, and the remote bucket ID to replicate writes to. And then once a replication stream is created, InfluxDB OSS will replicate all writes to the specified bucket to the remote InfluxDB bucket. And you can use the InfluxDB replication list command to view information like the current queue size, the max queue size, and the latest status code. And in some cases, I mentioned this kind of briefly before, you might not want to write all the raw high precision data to a remote InfluxDB instance. You might just want to write a downsampled or processed data. So in this case, we would create a downsampling task kind of just like we did before. And then we would write that to a downsample bucket and then create that as a part of our, or include that bucket as a part of our replication stream. We could be just simply downsampling our data, or we could be writing a Flux task that identifies certain conditions about our data and only writes that type of data to a bucket. So yeah, the sky's the limit. Options are up to you in your use case. And so the developer advocate team at Influx Data used edge data replication for our little project, one of our projects called Plant Buddy. And so this is the architecture diagram for our Plant Buddy demo. So in this project, basically, we want to monitor the health of household plants. And specifically, we want to monitor that data on the edge as an OSS cluster. We clean it up there and downsample that data before we send it to our cloud account. And then we add some alerts and notifications as well as visuals to go along with our project, because we create a whole UI for it as well. And so we use edge data replication to do that downsampling, to send that downsampled and processed data to our centralized instance. And so I encourage you to try InfluxDB and edge data replication for yourself. If you want to download InfluxDB, you can use the first QR code there on the left. And then if you want to check out Plant Buddy, as well as a bunch of other different projects that the developer advocate team at Influx Data has created, I encourage you to go to the Influx community organization as well. There's that Plant Buddy example there. There's that forecasting example with Telegraph in there. There's a collection of notebooks, Jupyter notebooks, with using the Python client library to perform forecasting and anomaly detection with a bunch of really popular Python packages, and a bunch of other projects as well. It's a good resource. Then last but not least, if you have any questions or you want to talk about time series at all, go to the forums, community.influxdata.com, or join us on Slack. I spend a lot of time answering questions on the forum, but I'm also in Slack, but come find me. And then again, InfluxDB University is a free resource. If that's the way that you like to learn, is through instructed-led tutorials and videos with examples. It's a great resource. I recommend checking it out. And some last resources, I mentioned these already, added some of the QR codes. There's also a book called awesome.influxdata.com that I wrote with another peer that is specifically for IoT developers looking to build IoT applications on top of InfluxDB. Then there's also our blogs, where there are a ton of tutorials for you to follow there as well. So now I will leave room for any questions and try and find.
Yep. So